Okay, hello everybody. So today we're going to continue our discussion in Chapter 5, Section 4, and I'm going to show you some application problems of using logarithms to solve the problems. So let's get started. The first example here says you invest $500 at an annual interest rate of 6.75%, compounded continuously. And they would like to know how long it would take for your money to double. So we need to jog our memory and think back into the very first section that we started talking about in this unit, where we discussed compound interest, where we had a formula for compounding continuously. That formula is A PERT, A equals PE to the RT. And so what this formula does for us is you can plug in your principal amount invested as well as the interest rate and the amount of time that you want to leave that money invested, and it will give you how much money you will have based on the conditions that you input into that formula. Well, what this particular problem does is it's asking us to figure out the length of time that it would take for our investment to actually double. So this is a little bit different than the other problems we've done so far using this formula, in that they're making one of the other variables stay a variable and we're going to have to solve for it. So what we're going to do is we will plug in everything that we can into this formula to see which variable we're going to solve for. So they said our initial investment right here, principal, is going to be 500. And they also said within the problem that our interest rate is 6.75%. So remember, when you have 6.75%, you do have to convert it into a decimal. So you would move that decimal place over 2 places to the left, and you would get 0.0675 for your R. Now, the thing is, we do not know the time. That's what we're trying to figure out. But what we do know is we want our money to double, which means our account balance after some set amount of time will be twice what we started with. Well, we started with 500, which means then our account balance should double and become $1,000. So what you can see right here is all of the information plugged in that we know from the problem. So we want our money to turn into $1,000. We started with $500. We are going to invest at a 6.75% interest rate. Now remember, E is the number E. It's not a variable, so we don't put anything in for that. And we are going to solve for the T in this case. So this is definitely different than the problems we've done previously, because we've never had to solve for a variable in the exponent position with these word problems using this formula before. So here's how you would do this. You want to isolate the base and its exponent. In this case, we want to isolate the e to the 0.0675t. So in order to isolate that, we will divide both sides by 500. Now, when we do that, what we end up with is 2 equals e to the 0.0675t. Now, the next step is we need a way to bring this down and get it out of the exponent position so we can solve for it. The way we will do that is we will take the natural log of both sides. We're using natural log here because the base of our exponent is e, and the base of natural log is also e. Remember, we want the base of our log to match the base of the exponent, so they'll cancel. So I'm going to take natural log of the left, and I will take natural log of the right. Now, in doing that, you can see this will allow us to utilize the power property to bring this down front, and then natural log of e will end up canceling. So what we're left with here then is natural log of 2 is equal to 0.0675t. Now, from there, we need to solve for t by simply dividing both sides by 0.0675. And we can grab our calculator to do that. And you can see that I will take and divide natural log of 2 by 0.0675. And I get an answer of 10.27. Now remember, in this particular formula, t represents time in years. So what this is saying is it's going to take a little more than 10 years, about 10 and a quarter years, for my money to double at 6.75%. Now, this is just a pretty nice looking graph here that shows you exactly what would happen to your amount that you started with at 500 and how quickly this amount is going up. And you can see that it's going up fairly quickly. Remember, this is an exponential growth, though. So as more and more and more time passes, this graph is going to get steeper and steeper and steeper. So the longer you could leave that money invested, the more money you will end up with, and the quicker that it will continue to grow. Okay, so the next problem I'm going to show you says the retail sales Y in billions of dollars of e-commerce companies in the United States from 2002 to 2010 can be modeled by this equation: Y equals negative 566 plus 244.7 natural log of t, where t is from 12 to 20. Now remember, t represents years. In this case, t equals 12 is 2002. So that means t equals 20 would be 8 years later, which would be 2010. So it says, during which year did the sales reach $141 billion? So if you think of e-commerce, this would be like Amazon or Walmart.com or things like that. As you probably figured out, this is going to grow, and it has been growing exponentially for quite a few years now. So we need to figure out, where do we put this 141 billion? Well, the 141 billion is the sales. And it does say that the retail sales in this particular problem are represented by the variable y. So in this equation, we will put the number 141 in for y. So we have 141 is equal to negative 566 plus 244.7 natural log of t. And so once again, we need to solve a variable. This time, though, the variable is being logged. So we do still need to peel the stuff away from it. So the first thing I will do is add 566 to both sides. So this will cancel, and I will get 707. Now, we still have 244.7 times natural log of t. So we need to get rid of that 244.7 by dividing it. And what we're left with is natural log of t is equal to 707 divided by 244.7. So now we're almost done, but we need a way to get rid of this natural log right here and get the t by itself. Now we can't just divide by natural log, because natural log is not multiplying the t. It's taking the natural log of t. The way that you get rid of natural logs, as we've practiced in previous problems, is that you need to convert it from its logarithmic form into its exponential form. And then you won't have a natural log there. The variable will be by itself, and you'll be able to solve for it. So if you recall, natural log's base is e. So the base of the log here is e. It becomes the base of the exponent. So this is e. And then the other two parts switch. So it's e to the 707 divided by 244.7 will equal our time t. So now we need to get our graphing calculator again and go ahead and type that in. So the e to the x is second natural log key. And you can see we have e to the x now. And then we'll type 7 0.07 divided by 244.7 and hit enter. And when we do that, you can see that it's 17.97. Now I'm going to just round that to 18. So T is about 18. So what does that mean within the context of our problem? Well, they did say that T equals 12 is 2002. Now, RT is roughly 18, so that is 6 more than 12, which means it will be 6 more than 2002. So what that means is that in about 2008, the online sales will reach $141 billion. Okay, that's what I have for you today. I hope you found both of those examples fairly easy to understand, and you'll have some homework problems that will also use logarithms where you'll use logarithms to solve them. And as always, if you have any questions, feel free to email me. Have a great day.